Good morning, good afternoon, good evening, or good night. Welcome to this research that we conducted with the title A Matter of Perception, where we investigated the effect of virtual reality on spatial understanding. The research is conducted by an international team, which I will now introduce, starting with Christina, who was the lead researcher, being one of our master students at Breda University, but who currently now works as an engagement manager at NetFlight. Then we have Tim van der Grinte, who works as an architect at Mood Builders, but also as the CEO of a virtual reality company called Enversed in Eindhoven, the Netherlands. Then, although I would love to introduce Shima first, I will first introduce myself as being Marnix, working as a professor at the Academy for Games and Media at the Breda University of Applied Sciences in the Netherlands.
Yes, and I am Shima, and I am giving this presentation together with Marnix today, and I'm a professor of architecture at University of Monterrey in Mexico. So in today's presentation, we are going to first talk about different media that architects and interior designers in general use to communicate the notions of a space with their clients. As you can see, different media each provide different means of communication, but there is always a question that which of those means of communications work best, which takes us to the notion of why for this investigation. The background of the research relies within the interior design and architecture, a special perception, and the role it plays in communication. To convey the information required for understanding the proposed design of the space to the client, experts communicate through different media, such as traditional drawings, 2D paper plans, mood boards, physical models, and 3D screen-based models and animation. However, this is a challenge as the level of spatial understanding between the expert and the client often differs significantly. What is a spatial understanding? The spatial understanding is defined as the ability to understand the shape, size, location, and texture of an object or space. Which brings us to the problem that which can be defined as how untrained minds have to use several cues and think carefully to understand the visualization of architectural designs. Experts understand these visualizations more easily and are able to translate them from the physical world into the virtual two-dimensional and three-dimensional world.
So one of the solutions to solve this gap might be virtual reality. So virtual reality might provide a better solution to close this gap between the professionals and clients in understanding spatial rooms and furniture. Virtual reality is of course not new, it's here for a long time, but since 2016 we now have affordable high-level virtual reality. It is perceived as very promising and a more effective medium for architecture and client communication, mainly because it is able to create a sense of being there. The capability of creating highly realistic and intuitive experiences might set VR apart from the traditional visualization media, which might have a risk of being too abstract. Technology used in VR helps explain why VR could work better compared to other media. For instance, the sensory technologies provide the user with a natural eye height and stereoscopy and a larger field of view, which might increase the perceived realism. Interaction and control technologies in VR might give VR a benefit as users can move and walk around objects, which imitates real-life behavior, and this might increase the understanding of virtual spaces. Also, VR allows for better location tracking, which may increase the sense of presence. However, research on the effect of different visualization media on spatial understanding is missing, or it's unclear in the outcomes. Some of the studies, they showed equal effects in spatial understanding between different media. But most of the studies compared different media and not these virtual reality media that we now want to research. And they have different spatial tasks. which makes it very challenging to draw unambiguous conclusions. No study so far that we have seen tested the impact of presence on spatial understanding or compared the desktop-based visualizations with the high-end mounted VR devices that we used in this study. So what we want to do is a research where we compare how people perceive space in 3 conditions: being in the real space, no medium involved, being in the virtual reality space, or through what we call now the traditional desktop screen. Both of them will show the same environment. So we use a between subject designs where participants, non-professionals, experienced an apartment through being in the physical replication of that apartment, either in real, either being in virtual reality using the HTC5 classes, or through a traditional desktop screen, which was a laptop with a 13-inch view. Participants could walk around the furniture from different perspectives. They could, for instance, kneel or bend sideways to look or discover one of those objects or furniture. After 2 minutes of getting used to the environment, they were asked to estimate the size of the room and the furniture that was present in the room. The participants in the VR and the media, the desktop condition, were also asked to fill out a questionnaire afterwards. We selected participants that visited a virtual reality center, because we wanted to reduce the newness effect. We wanted people that have a little bit of an experience with VR already. We didn't want to have any people that already are specialists with a VR, not only with the VR experience, but also in being design experts. Their age was 18 to 54 years with a normal or corrected vision.
The material that was used for this research included a room out of an existing loft apartment without any floor or wall, covering and included a table, 2 chairs, a bench, a kitchen unit, and a floor lamp. The room height of the loft is 5.08 meters and the length is 6.55 meters. The size of the furniture items displayed in the virtual environment corresponds with their real counterparts.
So what did we measure? We first wanted to know what the spatial ability is of all 3 groups. And to do that, we used the 12 items from a mental rotation test from Peters et al., in which the participant is asked to choose which of the 4 drawings represent the 2 rotated versions of the target figure. After we tested the spatial ability, we wanted to know the size estimations. So we asked the participants in all 3 conditions to estimate the depth, the height, the length of the furniture, as well as the room. Then after they did that, we asked them what their ease of the estimation was. So we asked them about the difficulty and the confidence of each of the estimations they used. And those 2 were combined into one variable, which we call ease of estimation. Next to that, we also asked them an overall impression question, which was please rate how well the medium could convey a good impression of the spatial dimensions. We also wanted to know how they felt the experience and the presence. For that, we used the ITC SOAPy scale, which contains 29 items over 4 factors: the perceived naturalness of the experience, the engagement, the spatial presence, as well as negative effects. And we finalized the research by measuring perceived usability. For that, we used usability engagement scale, which consists out of 9 items, which has items like I found the medium confusing to use, to I felt frustrated while trying to estimate the size in the displayed environments. So what were the results? What did we find? First, almost a precondition, we were happy to see that the 3 conditions didn't change or didn't differ from the spatial ability that they have. all groups had an average spatial understanding between the groups. Of course, the 7 experts that were in the study showed a much better spatial understanding. However, they were equally divided over the 3 groups. In size estimation, surprisingly, we also find an equal score, meaning that in all 3 of the conditions, they were equally able to estimate the sizes of the room as well as the furniture. They were fairly accurate. Only an overestimation of size in all of the conditions was a maximum of 29%, and the maximum underestimation was 7%. So the room dimensions as well as the furniture was accurately measured, or not measured, actually more estimated in VR and desktop. Although the desktop showed a little bit more of an overestimation compared to VR. In the ease of estimation, we found a small difference in favor for the virtual reality. So out of the 8 measurements we did, we saw that 2 of those, namely the floor lamp height and the length of the room, were more difficult and less confident to estimate when using the desktop compared to the VR. But overall, the estimation impression did not differ between VR or desktop. The sense of presence, the spatial presence, and mainly the engagement was stronger in VR compared to the desktop. And then higher engagement also meant a more ease of the size estimation, which explained almost 90% of the variance. Next to that, and finally, we asked him about the perceived usability. And again, we saw an equal score between virtual reality and desktop. However, we also saw that in virtual reality, participants were more likely to continue exploring the furniture as well as the room out of curiosity. Better perceived usability also correlated with a higher ease of estimation. And also, the higher the novelty, the higher the overall grade, negatively affects objective spatial understanding. So we still had to deal with the newness factor of VR.
So conclusion, the conclusion of this research was that VR and desktop both can be used effectively to estimate the space for simple objects and rooms. The finding supports the idea that VR has added value for less familiar and more complicated objects. VR was considered better and easier for sophisticated measures such as the height of an unfamiliar floor lamp or the length of the room. A possible reason for why VR worked better was the interaction dimension. Only in VR, participants could use their own body as a reference for estimating the lamp height. Because VR and the real-world condition achieved similar ratings for perceived spatial understanding, the general positive effect of VR, which is the predominant attitude in the industry now, can be confirmed. With increasing familiarity with VR, objective spatial understanding in VR may outperform desktop in the coming years, also on more simpler objects. VR also increases engagement and presence. However, we do not know anything about the subjective space estimation. How does a room feel? Therefore, we started a project, Being There, in which we will mix computer-generated VR with 360 recorded spaces and measure the effect of a spatial understanding for non-static unfamiliar rooms and objects related to the idea of a temporary home, specific to migrant women. Both the studies together will provide a better overview of the potential of VR in the understanding of the space. We would like to thank you for listening to our presentations, and if you would like to have more information on this project or the upcoming projects where we investigate the spatial understanding in space and the role of VR, please contact the authors in the following email or visit our project website in the following link. Thank you.